Chug.
Plug and chug. The only thing... Hold on. Okay, thank you, Miss Castles. Miss Castles, just chat if you want to in the lower left-hand corner. Can you see the screen? She might text or she might... Okay, she can see. Miss Wilson can see. How about Miss Castles? Because she has her... Uh-oh, somebody... Okay, there. Pendleton just came in. Okay, Miss Castles can see and she can hear. Pendleton, turn on your camera, please.
Hold on, the TV's not on.
That's fine. Take your time. So go ahead and write down the 6 trigonometric functions. I'm going to focus on the first 3. If you can do the first 3, you can what? You can do all of them.
Do the rest.
But you got to remember the chain rule. If you're taking the inverse sine of 4x, you've got to remember the derivative of 4x is what? 4. And you've got to remember to multiply by whatever's in parentheses. That's the only thing you have to be careful of when you're doing the inverse trig functions. You've got to remember that last step. Okay? So I've got, let me see what I've got here. I know I've got 2 or 3 problems, and then I've got some that I worked on. Derivative. Okay, here we go. Sometimes I get kind of crazy with my own notes, and I have to read them to make sure that I'm not all over the place. Okay, there's Miss Gusmus. Where's your other partners in crime? They're going to show up later, I guess, huh?
There's nobody here. The room was completely black when I came in.
Oh, my. Okay. All right, well, let's write down the problem. And let me hit the recorder. I forgot. I hit the recorder in the first class today, but it didn't record. So let me make sure the little... Okay, it is recording. Okay. All right, so the first problem is d dx. Find the derivative of the inverse sine of the natural log of x. Okay, now I'm going to go back and do the sine of 4x. Sine of 4x, and that's in parentheses, is going to be, okay, the derivative of the sine is the cosine of 4x, and then I have to multiply by the chain rule, which is going to be 4. All right, so my answer is 4 cosine of 4x. Now, with the inverse sine, you're not going to just say, okay, the derivative of sine is cosine. No, you're going to put the formula that goes with it. And then you have to worry about the chain rule. So remember, formula, then chain rule if needed. Okay, because if you have the inverse sine of x, you don't have to worry about the chain rule because the derivative of x is 1. But you always use the formula and then use the chain rule if needed. So in this case, you're going to have 1. You got to use this one right here. I'm just going to rewrite it. 1 over the radical or square root of 1 minus parentheses squared. Always use parentheses. And of course, what goes into the parentheses? Well, what's in the x spot? What's in this x spot? Natural log of x, Hubert.
The natural log of x.
Exactly. Thank you. I appreciate that interaction. Now, what? Now you take the derivative of what's inside and multiply by the function times 1 over what? X. And that's it. Now, if you can simplify, that's nice and neat, but not many teachers care. if you're at the inverse, if you're taking the derivative of inverse trig function, they don't really care about you getting it down to lowest, terms. They don't care. About the only thing you can do here is say 1 over x times the square root of 1 minus natural log of x squared. Now, do you see why I really don't put a lot of emphasis on the inverse trig function? Because if you know how to do the chain rule, and you know how to plug and chug into a formula, then the rest is just algebra. It's plugging and chugging and chain rule and algebra. All right, let's do another. Of course, they're going to get a little bit more difficult, but that's fine. You can handle it. Well, most of you can handle it. Some of y'all are just disappointments. D over dx of the inverse sine of e to the negative 2x. All right, go to it. Now again, there's really not a lot of calculus here as far as there is algebra. Actually, these are all algebra problems because the only thing you're doing, you are doing the chain rule, so that's about the only calculus you're doing. Really, this don't count as calculus because you're using substitution that you learned back in algebra. So here is my x right there. So I'm just going to rewrite this. 1 over the square root of 1 minus parentheses squared. And of course, that's what I do. Water walkers don't have to do that, but I do. And that's e to the negative 2x. And then I'm going to multiply, and I'm going to do this. Well, yeah. What is the derivative of e to the 2x? Okay.
E to the 2x.
Well, it's e to the 2x times what? Negative 2, because you got to do what's in what? Parentheses. So that's going to be multiplied by e to the negative 2x times what's the derivative of negative 2x? And this right here is nothing but the chain rule. So you plugged and chugged, and then you took the derivative of what's inside. See what I'm saying? You're taking the side, just like you did back in sine of 4x. But instead of doing the cosine, instead of doing that now, you're doing this. And then what do you have to do? You have to take the derivative of what's inside, which is right here. Everybody see that?
Yep.
So instead of doing the cosine, you're doing the radicals, whatever these things are. There's only the tangent. I think the tangent and the cotangent doesn't have a radical. All right, let's do another. I at least got to get some discouragement from y'all. I got to do something to discourage you. I actually did the derivations on these, but I'm not going to do the derivations because that's really You don't need it. All right, here's one. Now here's two. This is two test questions. It's also two homework questions. I got some more homework questions, but I wanted to put another test question, and this is find the equation. And I got another one also, so we got 2 or 3 of these. So let me go to find an equation. This is just find the derivative. Number 1, number 2. Let's find the derivative. Find the equation. This one will say find the equation of the line tangent to, you need to write that down. Find an equation of the line tangent to f of x is equal to inverse cosine, parentheses, x squared, at 1 over square root of 2, comma, pi over 3. What have they given us? What have they given us? They've given us a function, Hubert, and a point. Yeah, that's right, class. And what does this say? Find a what? Find an equation means we're going to use the point what? Point slope equation, Hubert. Thank you, class. So the first thing I got to do is find the derivative of the inverse cosine of x squared. Do that. Now you should be able to do it now, unless you didn't write down the derivatives like I asked you to do. It was up there for about, what, 15, 20 minutes? So I'll give you about a minute or two, and you should be able to do it because the second part of the question is nothing but Algebra 1. Somebody just left. I saw something blinked up here. Is everybody still up here? Brock's still here. Castles.
I think I lost connection for a second.
Oh, you did? Okay.
Yeah.
Now, when you, Swords, are you calling from somewhere easily? Are you at home or what? Mr. Swords, are you there? Uh-oh. Mr. Underwood left. Mr. Underwood, are you there?
Yeah.
What
I
happened?
just got to work and my phone trying to connect to Wi-Fi.
Oh, okay. Mr. Swords, are you back? Huh. Interesting. Mr. Swords, are you there? Oh, well. All right, so this is going to be -1. The inverse cosine is -1. I'll just write this over here for you in case you didn't write it down. The inverse cosine of x is going to be -1 over the square root of 1 minus x squared. So it's only a sign off. So that means that I'm going to take that x squared and I'm going to plug it in right here. So I'm going to rewrite mine because I do it this way. 1 square root of 1 minus parentheses squared. And that x squared is going to go right there. And then what is the derivative of x squared?
2x.
So the derivative of the cosine is the negative sign, which is this right here, which is, instead of doing the negative sign, we do this. And then what's the derivative of 2x squared? And that is right here. So we're doing the same thing, only the derivative of the inverse sine and the inverse cosine and the inverse tangent is not another trig function, it's a radical term. And you got to remember that, what you're doing. So when I do this right here, that's just like me going back a long time ago saying the inverse, or the sine of 4x, the derivative d dx of the sine is the cosine of 4x. That's what I'm doing right here. And then I have to take the derivative of what's inside, and that's right here. If you don't explain it like that, some students will get confused. And they'll say, well, wait a minute, I'm supposed to take the inverse cosine. Isn't that going to be the inverse sine or whatever? They get confused. Now all you need to do is simplify. And that's going to be negative 2x over the square root of 1 minus x to the what? 4th? Now, you could take the square root of that, but I just leave it alone. I just plug my numbers in. Okay? And when you plug your numbers in, you only have to plug in 1/2 because you want to find the slope. So I want to find the slope of the tangent line. And that's going to be equal to negative 2 times 1 over the square root of 2 over square root, what is that noise? 1 minus parentheses to the 4th, and I'm going to put 1 over the square root of 2 right there. Now calculate that out. And after you calculate it out, I think you come up with negative 4 over the square root of 6. So I'm just going to put dot, dot, dot right here. And if you were in Dr. Harden's class at Clemson, he would just draw an arrow and go, that means you know how to do this. It took me like 3 weeks into the semester to figure out that's what he meant. Don't think I'm kidding. I'm not. And Dr. Russell, we'd have to send somebody from class in advanced calculus 2. He was the only one that taught it. And we'd have to send somebody from class to his office every day at class time, knock on the door, because he would be in there playing Tetris on the computer. And he would miss class if you didn't go up there and get him. Y'all think I'm kidding? But okay, nobody's going to talk to me, so I don't know why I'm trying. I get negative 4 over the square root of 6. Y'all check me. Somebody needs to confirm it, make sure I didn't mess up. And you can do it on your calculator and get a decimal. Just make sure it's the same decimal with negative 4 over the square root of 6. I think that's what it got. Okay, I'll just do it. Equals negative 2 over square root of 2 over square root of, or 1 minus, well, 1 to the 4th power is 1. The square root of 2, you could say that's 2 to the 1/2. 2 to the 1/2 raised to the 4 is 2, that'd be 4? Somebody check me. I think that would be 4, I'm not sure. Let's see, 1 square root of 2, 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 1 square root of 2. 1 square root of 2 times square root of 2 is what? 2, right? Okay, 1/4, not 4, 1/4, I'm sorry. 1 over 4. I don't know why I'm not using my notes, I never do. Anyway, equals negative 2 over square root of 2 over the square root of, what is 4/4? Be 3/4? What the heck was that? Okay, cats are loud. Dog start barking. We're not gonna. I ain't gonna have none of that. All right, so that's gonna be negative 2 over the square root of 2, and then you multiply. That's gonna be 2 over the square root of 3. Negative 4 over the square root of 6. Dang, I'll tell you what. Okay, Hubert, that's right. Thank you, class. Y'all suck. Now what do we have? Tell me what we have now.
The points and the slope.
We have a slope and a point, so now we're going to use what? Point-slope equation. So plug and chug. And yes, this is a test question, so make sure you have it in your notes and make sure you understand what the heck to do. So our slope is whatever that is. And if you want to rationalize the denominator, go ahead. But you got a square root symbol right there, so it might help you to leave the radical in there. M is equal to negative 4 over the square root of 6. And my 1 square root of 2, comma pi over 3. Y minus pi over 3 is equal to negative 4 square root of 6 times x minus 1 over the square root of 2. Y minus pi over 3 is equal to negative 4 square root of 6x minus, be a plus, 4 over the square root of 12. Y is equal to negative 4 over the square root of 6x plus 4 over square root of 12 plus pi over 3. Now, the good thing is, I don't know, I might not be able to get a common denominator for 3 square root of 12. Well, before you do that, 2 square root of 3 is 12, right?
Yes.
Thank you. 2 square root of 3. So 6 square root of 3 on the bottom. Yeah, get a 6 square root of 3. I don't know if that'll help or not. Let's just see. Y is equal to negative 4 square root of 6x. And then 2 square root of 3 be a 6 square root of 3 plus, I'm just going to put 6 square root of 3. 2 we're going there 3 times, that will be 12. And then 3, we're going there 2 square root of 3 times plus pi times 2 square root of 3. That really ain't going to make any difference. The final answer is going to be y is equal to negative 4 over square root of 6x plus 12 plus, you could actually, somebody with a calculator could do that with a, I think we'll just leave it at this. That would be probably your final answer. Unless they ask you to do it, and if they did want you to do it approximate, yeah, that's what I got. Plus pi over 3. Okay, there it is down there at the bottom, right here. Pi over 3. Just forget about that 2 square root of 3. Make that just, you can leave that as 2 square root of 3, or you can leave it as square root of 12, either one. Capiche?
Got it.
I got a couple of word problems, but we're going to do those later. I'd like to go over a couple of, let's go over another. I'd like to go over the short and sweet problems before I go over those word problems. So let's do another one. Let's do, and this is one that's a little bit more challenging. F of x is equal to inverse sine of x squared. Now this is not that bad. You going to have to use the chain rule, but you got to use the power rule with the chain rule. So go ahead and do it. Go ahead and bring your 2 out front, and then multiply by what's in the parentheses, and that's where you're going to use your formula. Why can you not just plug it in the formula? You could if it was the inverse sine of x. Is it the inverse sine of x? No. It's the inverse sine of x raised to the second power, which is same comparing a cat to a tiger. Okay, it's got 4 legs and a tail, but it's not the same thing. Yeah, I understand that, Hubert. Oh, okay, thank you. Do y'all sit in y'all's other classes and not say one compounded word?
Not always.
Why you do it in my class?
Because I really don't like math.
No, is that what it is? Okay. It won't be the first time I've ever heard that. I should have just taught basket weaving. Is what I should have taught. I should have got my degree in basket weaving. Or what is it called? Global studies. That's what I should have got. So, here we go. Use the power rule first. And that's going to give us 2 inverse sine of x to the 2 minus 1. And now, I'm going to take my blue marker. This is in parentheses. And now I'm going to do 1 over the square root of 1, I always have to look, minus parentheses squared. And what goes in there? X. Now simplify it. You're not going to be able to simplify it very much.
Just make it x squared.
Yep, and that 2 will go up to the top. So your final answer will be f prime of x is equal to, well, that's going to be, that 2 will go right here, and that whole thing right here can go up to the top. So that's going to be 2 sine inverse of x to the first power over the square root of 1 minus x squared. And of course you don't need to the 1 power, so you can leave the brackets, or you can what? You can take the parentheses off. It doesn't matter since it's to the first power. So you can take that off, and that's your answer. So how hard is, if you know your chain rule and you know all your basics, how hard is it to do the inverse trig functions?
It's not bad. It just takes some time.
It just takes some time. Exactly. It just takes a little bit of time. You know, it's not Beethoven's Fifth. Now, if you want to take the power rule, the product rule, the quotient rule, the chain rule, that might be Beethoven's Fifth. But if you know that, this is like Mary Had a Little Lamb. You take your basics and you just plug and chug. So that don't discourage you enough. We need to do another one to discourage you. Thought I'd have somebody discouraged by now. F of x is equal to inverse cosine of brackets, not brackets, but parentheses, 2t, or 2x, whereas I can't even read my own writing, 2x minus 1. Now this is not cosine squared. This is just the inverse cosine. So instead of the inverse cosine, you're going to put a big old radical with a 1 on top of it. And then you got to take the derivative of what's inside of the parentheses, which you got to rewrite that because you can't, radicals in calculus don't what? Don't mix, Hubert. Thank you. Now the only difference between the inverse cosine and the inverse sine is a -1 on top. So f prime of x, and what I'll do, just to kind of help y'all out, since I don't have posters, I'll put this in blue, and that means -1 over the square root of 1 minus parentheses squared. And what goes into that? Well, that square root, let me make that a little bit bigger because I want to rewrite that because I don't like having the radical in there. I'm going to make this a little bit bigger. There we go. And I'm going to put 2x minus 1 to the what? 1/2 power raised to the what? Second power. Oh, look at there. Look what happens. That's nice. Well, I can't make that. Things I do for y'all. One minus parentheses squared, and this inside parentheses is 2x minus 1 to the 1/2 power. There we go. We're cooking with peanut OIL now. Now I'm going to write this in magenta. It's going to clash, but be all right. Put that right here. And I'm going to write right here, I'm going to say, okay, this right here is 2x minus 1 to the 1/2 power. Everybody with me? So I'm going to rewrite that as 1/2 2x minus 1 to the -1/2 power times parentheses. What's the derivative of 2x?
2.
Now, finish it. This will reduce a little bit. Not much, but it will reduce a little bit. They want me to be on a committee about the online classes versus the synchronized classes. And one thing that I'm going to make mandatory, no offense to y'all, but the videos have to be enabled. Not for this class, but for the online classes, the videos have to be enabled. Because it's hard for me to discern what y'all are doing if I don't see you writing, or I don't see you looking down at a piece of paper, or don't see you. See, I can tell what Pendleton's doing, I can tell what Easley's doing, but I can't tell what the rest of y'all are doing. So that's why I think it's imperative that videos be turned on in future classes, because a lot of times the teacher looks to see what the students are doing. So So what happens to the 1/2 and the 2?
They cancel.
They cancel. And this right here cancels. So we can reduce that in the radical. So let's just rewrite the whole thing. And I'm just going to rewrite this as f prime of x is equal to -1 over the square root of 1 minus 2x plus 1. Y'all check me there. Times.
It should be 2x minus 1.
Say again?
Never mind. I forgot to
Yeah,
change
I'm doing it step by step, but thank you. Okay, 1 over, well, that's going to be the square root. So I'm going to go ahead and write square root of 2x minus 1. And this is going to be it. F prime of x is equal to, that's going to be times, so that's going to be -1 over, and you can put the negative with the 1 or you can put it out front, the square root of -2x plus 1 times the square root of 2x minus 1. And I think that's what I have. Yep. 2x plus 2. Sorry. That's a good test question. Where's my clock? Well, I can go 5 more minutes. I want to do this last one. Here's the last one, and then we'll save Monday for word problems. And then I can go ahead and probably, well, no, I'll just go ahead and put the test up this weekend. We'll just have this one. And then I'll leave y'all with 1 day to send in homework problems Monday. Okay, here we go. Y is equal to inverse tan x over a plus natural log of the square root of x minus a over x plus a. Now the first thing I'm going to tell you to do is rewrite as much as you can before you even start doing the calculus. At least a couple of steps. There's a couple of steps you can actually do there, and I think you're going to focus on what? The natural log. That's supposed to be inverse tan, sorry. Inverse tan. So what can you do with this? First of all, you can rewrite the radical as what?
To the 1/2 power.
To the 1/2 power. And what? Bring the 1/2 out front temporarily. Oh, I'm trying to kill 2 birds. I don't want to skip too many steps. X minus a over x plus a. Now what can I do with the natural log of something over something?
You can do the natural log of each and subtract it.
Subtract. Use the quotient rule. Quotient rule. Remember, the quotient rule of exponents, the quotient rule of logs, the quotient rule of derivatives. They're all the same. Whenever you divide, you can what? Rewrite it as subtraction. That's called the quotient rule. Tangent, -1 of x over a plus 1/2. And you can put the 1/2 with it again. That's why I said temporarily pull it out. Natural log of x minus a minus the natural log of x plus a, brackets. Now you can distribute the 1/2 back. You didn't have to do that, But as far as teaching people, it's a whole lot better to do it that way than to try to explain how to get the 1/2. It's easier to do it that way. Y is equal to tangent of x over a plus 1/2 natural log of x minus a minus 1/2 natural log of x plus a. Now you are ready to do the derivative. Now look, the derivative is actually the last few what? Steps. So again, we are at 80%, 90%, whatever you want to call it, algebra, and the rest is calculus. Treat A as a constant. Okay, they should have said that in this problem, but they didn't. Treat A as a constant. So like 2x plus 4. The 4 is going to, drop off because it's a constant. Not with the tangent. In tangent, you're going to stick that in there. So with the tangent is tangent and cotangent does not have a radical. So y prime is equal to, and instead of the tangent right here, you're going to put 1 over 1 plus x squared. 1 over 1 plus parenthesis squared. Plus 1/2. What is the derivative of the natural log of blah, blah, blah? Well, du over u. What's the derivative of x minus a? 1, because that's a 1 right here. And that's a constant. 1 over x minus a. Minus 1/2 of 1 over x plus a. And what goes in this spot? X over a. And now you can finish it up, but there's really nothing left because the next step I got it boxed in. That's it. That's pretty much it. You could get x squared over a squared right here and make this a squared over a squared, and you can simplify it right there, but that's it. And this one here, a is considered a constant. When you take the derivative, and you don't have to worry about it here because this is plug and what?
Chug.
This is plug and chug, so you're not going to do anything with this anyway, like as far as taking the derivative of it, so you don't have to worry about it. Hopefully you see now why I wanted to test you so much on the basics and then the logs. Because now this shouldn't be that much trouble. Capiche?
Yep.
Okay, now you're able to do 3.9 homework, and I'll put about 5 or 10, maybe even less, 3.10. We have gone over 10 sections which is really 2 units. Okay? But I broke it up into 3 tests for y'all because, not that I care about y'all passing or anything, but it's easier to do the basics first, then do the natural logs, and I meant the implicit, then do the natural logs. So expect the test to go up today or tomorrow, and you'll have the weekend to work on it for those that want to work on it. For those that want to expand till Tuesday, it'll probably cut off Tuesday. Everybody got it?
Yep.
That means Monday and Tuesday, you better be sending in some questions. If not, then I'm going to go ahead and hit the last unit, which is going to be a conglomeration unit. It's going to be like 2 units together, but it's not going to be a lot of unit 3 because you already know how to do that. All right, questions? As long as we get antiderivatives in, we're good.